Alright, today we're going to show you how to name binary ionic compounds with Group A metals and Group B, which are also the transition metals. And you have to understand that when you name a compound, you're going to have to find the first element on the periodic table, because where the first element is going to determine how you actually name it. And if you're not doing that, you'll miss a third of them, because when the first element is a metal that you know the charge of, and the second one is a non-metal, that would be an ionic compound. So a metal that you know the charge of and a non-metal, you simply name it, drop the last syllable or last couple of syllables of the non-metal and add IDE, and that's the name of that compound. Again, example is sodium and chlorine. That's table salt. What you call that is sodium chloride. You just drop the last syllable. So which are the metals that we know the charge of? So we know this column, we know this column, and we know aluminum, zinc, silver, and cadmium. And that's it. The rest of them, Group B transition metals, we have to add something to the name to indicate their charge, because they can actually have more than one charge, and it's because of those d orbitals that that's the case. In other words, iron can be +2 or +3. Copper can be +1 or +2. So we have to know that when we name that compound. So again, we know column 1, column 2 metals, aluminum, zinc, silver, and cadmium. We're talking about binary ionic compounds. Binary means just two things. Ionic means it is a metal with a non-metal. When you're writing these compounds, the metal always goes first. And again, the Group A metals, again, are the ones we know the charge of. So in Mg and O, what we call that, magnesium and oxygen, drop the last couple of syllables, magnesium oxide. Again, and you have to understand, like I say, you will have to, when you're doing all these, when they're mixed up, you have to know, we know the charge of magnesium is in column 2. Sodium is right there, so that is sodium sulfide. So if you look up the next one, it's zinc sulfide, so there's zinc. Again, it's in the transition metal category, but it's one of this group over here that we actually know. Zinc's charge is always 2. And so we need to that's just zinc sulfide. The next one, there's potassium right there. So we know its charge. So again, so that is potassium. Instead of calling potassium chloride, drop the ending of the last of the non-metal, and you're just adding IDE. That's all you're doing. The next one there is barium, and so there's barium, so we know the charge of the metal, so that is just barium oxide. Very simple. You do this stuff, get started. Again, we know zinc, so there is zinc chloride, and again, we know aluminum as well. The charge of aluminum never changes, so that is aluminum fluoride. Again, all these on your own. You can do the problems on your own there at the bottom and check your answers. The answers are at the back of the notes, so that you can always make sure you know exactly what we're doing. All right, so there's that, and there's the rest of them up there at the top of the page that you can do on your own. And now we're going to get to how to name binary ionic compounds with transition metals. So again, the transition metals are those in here that are not circled there. Transition metals, also you have the post-transition metals over here that can also have more than one charge as well. So again, like I say, when you name it, you got to find the first element. So we're trying to name this compound. If we use the rules we just used, we would just call that cobalt iodide. But we got to find cobalt. Cobalt's in there. Cobalt can have more than one charge. So what you actually have to do is you cross the charges, to write a formula. You have to uncross them to determine what the charge of cobalt was. And the first thing you do is you always check the charge of the non-metal. Now, a lot of people ask, why are you checking the charge of the non-metal? Because we know the charges of the non-metals. They're the non-metals. They're either -3, -2, or -1. And then that's going to allow us, when we check the charge of the non-metal, that will allow us to determine whether or not the compound has been simplified. Because when we write a Roman numeral, so when you write, anytime you write the name of a compound with a transition metal that we don't know the charge of first, you have to include a Roman numeral in the name to indicate the charge of that element. We don't need to know how many there, we just need to know what its charge was. So you have to uncross the charges. Remember, we cross the charges to put them together. you have to uncross the charges to determine the charge of the transition metal. So we always check the nonmetal because we always know their charge. There is iodine right there. It is -1. So again, the charge of iodine is 1. We don't have to write a 1 in a formula, so that means they have not simplified that. That means the 2 came from the charge of cobalt. When they cross the charges, put that together, that's why that is cobalt, Roman numeral 2 iodide. The next one, copper. Again, copper, we don't know its charge. And so we've got to then use the Roman numeral to indicate what the charge was based on. Again, we have to uncross the charges to determine the charge of the transition metal. We check the charge of oxygen because, again, we always check the second element of non-metal because we always know their charge. And oxygen's charge is 2, but notice, they've changed it to a 1, which means they've simplified it. And if they simplified oxygen's charge, they've simplified copper as well because that's the way it started. Because if you're trying to put 2 elements together, you know, copper and oxygen, and both of them charge are 2, the first thing you do before you cross the charges is simplify them if you can. So that means the charge of copper started off as 2, and so that is copper Roman numeral 2 oxide. I know there's not 2 coppers there. That's not what we're asking when we're trying to name it. We're trying to say what was the initial charge of copper. And again, if you want to work, you know, if you look at it the other way, you go, okay, I'm going to put copper with a +2 charge together with oxygen and it's -2, and I want to say what is the formula for that. Remember, you would have to simplify it first, then cross it. That's how you end up with CuO. But the original charge was +2. So that's the difficult thing about dealing with transition metals. The compound may have been simplified, and you always have to check for that. So again, here's practice on this stuff. There's copper. We don't know its charge. That means we can't simply call that copper bromide. We have to look at the charge of bromine. There's bromine right there. Bromine's charge is 1, and that means they didn't simplify it because they don't have to bring a 1 down there below copper. 1s are understood in the formula. That means the 2 came from copper. So that would be copper, Roman numeral 2, bromide. Again, we're uncrossing the charges to determine what the actual charge of the transition metal is. Again, we're starting with copper again. We don't know the charge of copper, so it needs a transition metal in the name of the compound. We'll look up selenium. There it is. Its charge is -2. So, and look what they've done. They brought the 2 down like they were supposed to. They didn't bring a number down from copper. The only number you don't have to bring is 1. And it's understood in a formula. So that would be copper, Roman numeral 1. That was the charge of copper. And then that would be selenide. Iron sulfide. There's iron. Again, it's a transition metal. We don't know its charge, so it's got to have a Roman numeral in the name. We can't call it iron sulfide. That's incorrect. So you look up sulfur's charge. There's sulfur right there. Its charge is -2. They didn't bring the 2 down. Why didn't they? It means they've changed it to a 1. That means they've simplified it. And that means this one had to have been simplified as well. That means the iron then had to have started out as 2. So it's iron, Roman numeral 2, sulfide. Next one, check the charge of chlorine. Chlorine's right there. It's -1. And so, again, all those in column 7 have the -1 charge. And so chlorine's charge is 1. They didn't bring the 1 down because they didn't have to. And so where did the 2 come from? Had to have came from the charge of chromium. Again, chromium needs a Roman numeral because it's right there. It is a transition metal. So that would be chromium, Roman numeral 2, chloride. And let's see if we have another one there on the next page. Yeah, we got one more. So we've got Fe and N. And let's see. All right, Fe, there's iron. Transition metal first again. We don't know the charge of iron. We got to check the charge of the nonmetal because, again, we always know the charge of the nonmetals. Nitrogen's charge is 3. Again, you have to ask yourself, why didn't they bring the 3 down? Well, there's only one reason they wouldn't do that. It's because the whole thing has been simplified. So that 3 has been changed to a 1. That means iron's charge has been changed to a 1, which means that iron also had to be 3 as well. And so that compound is iron, Roman numeral 3, nitride. Again, we're still just changing the name of the nonmetal. dropping the last syllable, sometimes the last two syllables, and adding IDE. There's some practice on your own as well. Good luck with that. Let me know if you need any help.